Okay, so let's start with what is sustainable aviation, right? So sustainable aviation essentially means that we meet the needs of aviation today without compromising the needs of the future generations. In other words, sustainable aviation is achieved by aiming towards a zero carbon footprint, as mentioned by Walker et al. In 2009. So the road to sustainable aviation basically means the road towards zero carbon footprint. However, zero carbon footprint is very far away. The initial goals in the country were 2035, but they have been pushed now to 2050. So globally, the aim is to obtain zero carbon footprint around 25 years ago, 24 years later from now. Now, how do we do this? We focus on reducing certain aspects. One is the emissions, the carbon emissions which are being generated, we try to reduce them. We try to move more and more towards the non-renewable resources. And we also try to reduce the noise pollution. By the way, noise pollution is a big problem. And it is coming in way of sustainable aviation because lots and lots of communities, especially near the airports, are becoming very upset because they are not able to get peaceful sleep, or they feel terribly disturbed because of the increased aviation operations. Steps towards sustainable aviation involve innovations, and these innovations are in many fields. This could be in the area of fuel. We have what is called as sustainable aviation fuel, or SAF, which is nothing but creating usable fuel or blending the fuel, blending the fossil fuel with fuel generated using biological products such as Jetropa or many other produces. When we use only a percentage, we call it as blending. So 5%, 10%, 20%, 50% blending. But eventually, our aim is to, if possible, go for completely non-fossil based fuel propulsion system, which is difficult to achieve, but not impossible. We can also have innovations in operations, such as operating the aircraft with lesser wastages. There are many ways of doing it by the air traffic management agencies, by the airlines. But one of the approaches to lead to sustainable aviation is also to design newer and newer systems. And today we will discuss under this category. Okay, so let's understand what is meant by buoyancy engineering. So we are proposing that buoyancy engineering can be used for sustainable aviation. Buoyancy engineering can be phrased as creative problem solving by exploiting buoyancy for lift generation. The genesis of buoyancy engineering is the famous, well-known Archimedes principle, which acts on a body which is partially or fully submerged in a fluid. And it says that the upward force of buoyancy acting on the body which is submerged in the fluid will be equal to the weight of the fluid displaced. This particular principle is also applicable to a fluid within a fluid. For example, when we boil water in the morning to have a cup of tea or coffee, after we generate heat, the air which is condensed inside the water will start becoming vapor. And since the buoyancy of vapor or the density of the vapor is less than that of the fluid, buoyancy force will make it go up in the form of bubbles. So the bubbles that we create in boiling water are because of the application of Archimedes principle on a fluid such as air inside a fluid such as water. Now one can apply Archimedes principle to use buoyancy engineering for beneficial applications such as hot air balloon. We are all aware about how hot air balloons work. In fact, in the last session, I think I had discussed about the flameless indoor hot air balloon exercise that we do. Okay. So hot air balloons are very well established application of Archimedes principle or buoyancy. We are all aware about submarines also. These are they use buoyancy of air on bodies submerged in water. And finally, we have what is called as airships. And that is what we will discuss today. The students of this particular course definitely know about airships a lot because we have already reached the second month of the 3-month course. So I'm sure by now you know about airships, what they can do, what they cannot do, what are their merits and demerits. Okay, so we will look now today at how airships can be helpful in sustainable aviation for the future. So one application of airships which has been touted as the best application of LTS systems in the coming years is to use them for transporting large size and heavy cargo. But before we go there, we should first try to understand how cargo is transported today. So today, you have an option of transporting cargo either from a ship or a train or a truck or an airplane. These are the options available today for transporting cargo. Now, what does this flow represent? Basically, if you look at a plot between the cost of transporting cargo in terms of dollars per ton mile, a very commonly used unit to talk about transportation cost. So cost per ton of material carried per mile of distance. If you plot that versus the vehicle speed in knots or nautical miles per hour, we can see in this image that the ship is the slowest but the least expensive option. The airplane is the fastest but also the most expensive option. Broadly speaking, the cost of transporting by airplane per ton per mile is 60 times more than that of a ship. For a truck, it is 25 times approximately. And for a train, although the speed is much larger, the cost is relatively less, about $3 to $4 per ton per mile. But undoubtedly, ships are the least expensive, and that's why all over the world, heavy cargo is transported only using shipping lanes. The current scenario in the world is such that we are in the middle of several wars. And in the Strait of Hormuz, as you all know, many ships are stuck with petroleum products, including those from our country. So we were fortunate that 2 of these ships were allowed to sail through the Strait of Hormuz. But interestingly, each ship corresponds to only about 85% of the country's requirement of LPG for one day. So by 2 ships, we have only got enough LPG for about 2 days of consumption. So much is the dependence on the ships for our energy needs today. On the other hand, if you also look at comparison of the transportation mode with the greenhouse gas emissions, that is grams of CO2 or CO2 equivalent produced per ton per kilometer, we will notice that aircraft has got a very, very polluting contribution of close to 1647 grams of CO2 equivalent per ton kilometer, as compared to a cargo ship which is less than 100 times, about 13. Rail is almost double of the ships. Heavy ground vehicles, such as the trucks which are used to transport cargo, is about 106. If we use A diesel van, it is around 580, but if you use electrical van with battery, assuming that the battery is produced using, environmental friendly means, then it is 251. But look at the bottom. If you operate an airship, and that too with electrical propulsion, it's 1/3 of the ship. So from the point of view of the greenhouse gas emissions, electric airship is 400 times better than an aircraft, 400 times, and even 1/3 of the cargo ship. So that is why airship fits this particular gap between the truck and the airplane. So it is faster than the truck, but less speed than the airplane. Its operating cost is on the ballpark of $45 per ton mile, which is more than the truck. You can say double the truck, but nearly 2/3 of the airplane. So that's why we say that airship occupies a special niche between the truck and the airplane, both in terms of the speed of delivery as well as the cost of delivery. So for the near future, airships offer a very promising mode of cargo transportation. And that's why all over the world, there are agencies and companies working on developing larger and larger cargo airships for national and international transportation of cargo. So buoyancy engineering, it can directly be useful for sustainable aviation because of three factors. The first is it reduces the fossil fuel-based thrust dependency. Secondly, it enables low energy hovering and vertical landing, which is a unique feature of airships because unlike aircraft, unless they are fitted with a very specific kind of a power plant, it is very difficult to provide facility for hovering and vertical landing. But airships can do hovering and vertical landing with lesser energy requirements. And also, buoyancy engineering supports quiet and low emission air transportation because I would say quieter and lower emission because they also do some emissions. I would just say it's quieter as well as lower emissions. And if we use electrical propulsion systems or hydrogen-based propulsion systems, then we can say that it is no emission or zero emission also. But we are very far away from actually achieving a large fraction of cargo transportation using airships. In fact, right now there are no cargo airships commercially operating. They are all being proposed and they will come very soon. But they are on the road and you will see them at least, hopefully, in my lifetime. Now, what are the applications of sustainable LTS systems? One could use them for aerial surveillance and monitoring, which is the primary use of LTS systems all over the world, and it will continue to be. And for this application, if we use aircraft or helicopters or any other mode of transportation, they are very much fuel inefficient. One could use LTS systems as airborne communications relays, both stationary aerostats as well as mobile airships. You can mount your communication equipment on these systems and make them stay at a place at a high altitude or move around at high altitude, providing a facility for airborne relay of the communications. As I mentioned, you can use it for cargo transport in remote areas because at both the places you don't require to build an airport or provide a runway or any other special facility. Airships can operate from open fields. So for a point-to-point transportation system, they will be very good. Of course, we require some storage facility for the large size envelope of the airship in some kind of a hangar, at least at one of the two locations or at the primary storage location. But there are solutions available even of keeping airships out in the open with anchoring them safely to the ground. and by transporting the loads acting on them onto large pieces of fabric which are wound over the envelope if possible. So there are solutions available. In fact, there are also inflatable hangers available now, which can be set up at a particular site temporarily and removed and relocated as the airship is also moved. Airship can also be used for tourism and short-haul passenger travel. This is the current application for which we see passenger carrying airships. Otherwise, they are mostly used for surveillance. Now, there is a very beautiful video that shows the tourism and short-haul passenger application of airships. But because that video is on YouTube, we are unable to show it here because it will then lead to a copyright violation. So what we are doing is we are just showing you, or we are flashing the link of the YouTube at your leisure. After this particular recording is available online on the YouTube channel, you can go and have a look at this link and you will enjoy a short film on application of airships for tourism and short-haul passenger travel. Moving ahead, let us see how airships can be used for transporting cargo in remote areas. So there are some concepts which have already been realized, and then there are some concepts which are currently under a proposal stage. So first we will show you images of two concepts. One of them on the bottom is called as the flying whales. This is the concept which is under advanced stages of investigation. And if all goes well, we should be able to see them operating very soon. The one on the top is the Atlant concept of Atlas LTA. That's also in the advanced stages of research. On the right hand side, there are two concept prototypes. Or I should say, these are prototypes of concepts which have successfully flown. So the one on the left are under realization. The one on the right have already been flown. The most interesting and promising among these is the one on the bottom from the company called as LTA Research. It's the Pathfinder 1, which you can see in this picture is flying in San Francisco Bay. This trial was held last year, and every week we get updates on LinkedIn about their new developments and process. I'm very happy to also share that some of my ex-students are working in this particular company and they are contributing to this research and development project. Eventually, they are right now it can only lift 1.5 tons of cargo because it's a prototype, but they are planning to upgrade it to around 20 tons of cargo or maybe more at a later stage. The one on the top is a prototype of a cargo airship developed by my very good friend, Professor Barry Prentice from the University of Manitoba in Canada. So I'm told, unfortunately, that his prototype was damaged in a snowstorm, but it has successfully flown. And this is an image of just January last year. Previous prototype that he had developed was lost in a snowstorm, but this one is successfully flown. There are some questions on the live session, which I will take. Okay, so there is one which says, are there countries which have genuinely started working on using airships as cargo? And if yes, which ones? And is our government planning any funded projects for the same? So the answer is yes to all. As I'm showing you, flying whales is a concept from France. Atlas concept is from the US. Then the one from Canada, the bottom one is from US again. And there are also other agencies who are trying to develop. In India also, there are some private companies which have started looking at cargo airships. And I am not aware of any government funded project, but I'm aware that there are some private sector players who are looking seriously at development of cargo airships. And they are also collaborating with companies like Flying Whales to realize such airships in India. So now we have to distinguish that the airships that we are proposing for carrying cargo, they are probably going to be rigid airships. You know, there are various kinds of airship configurations, rigid, non-rigid, semi-rigid. So the rigid airship is the one that is most amenable for heavyweight cargo transportation. So what is rigid? Basically, rigid means it has got a framework which is stiff, a complete internal structural framework. It could be metallic or it could be composite, but the shape is held by the stiff internal structure in a rigid airship. Now, the lifting gas in the rigid airship is not put as one big compartment, but we put it in various unpressurized cells in between the various frames of the rigid airship. So the lifting gas is not going to come in contact with the skin of the airship. It will have separate gas bag in which the lifting gas will be placed. Here is an example of the famous airship called Hindenburg. Most people, when they hear about Hindenburg, they remember that video where it is, catching fire at the rear side, coming into land. But people forget that several successful flights of Hindenburg across the Pacific Ocean, more than 10 flights were conducted successfully. Okay, so I think we will do a disservice to history if we consider Hindenburg as a disaster or as a unsuccessful airship. It is one of the most successful airships of all times. Okay, it was the last of the great airships. Before it was lost, it had transported 2,800 passengers and it had flown more than 186,000 miles successfully. So you can see these gas bags which are located within the frames of the rigid structure. These are, you can compare the size of the small cranes that you see on the bottom versus the size of the envelope. And now you can see the fully inflated gas bags, how large they can be. This is how they were installed inside the structure. The question that comes to our mind is, why rigid cargo airships? Why not look at semi-rigid, which is already proven, certified? Or why should we not look at non-rigids, which are much lighter? The internal framework is very important because the loads that will be coming on these airships are going to be very, very high. We are looking at cargo airships with 20 tons, 60 tons, 100 tons payload capacity. So the load that will come on the structure, and because of that, the kind of stresses that can be generated very, very high. And because of that, a rigid framework is very useful because it can distribute or it can bear these stresses. The other point is that when you carry heavy and concentrated weights, a rigid structure will give you higher redundancy. Then it will be able to withstand the vagaries of the weather in a much better fashion because of its inherent rigid structure. Then another important point is the scaling advantage. In LTS systems, bigger is always better. That is because when you increase the dimension of any body by 2 times, such as the cube that you see, if you double the length of the cube, you will get 8 times the volume. And volume is what gives you buoyancy. So this is called as a square cube law, in which the improvements multiply exponentially when we have larger sizes. Now, because of the square cube law, you will get much, much higher lift compared to the weight when you make the airship larger. And a rigid cargo airship will also help in lower LTA gas leakage because the skin is not directly connected to the lifting gas. The lifting gas is inside the gas bags and the structural envelope is away. Now, there are many modern innovations which have paved way for development of much more rigid and capable airships. Earlier, we were using only metallic structure for the skeleton of the airship, but now we can use carbon fiber composites, which are available now. These are the systems with very high strength to weight ratio. One can also reinforce the stress points with titanium hubs or with Kevlar reinforcement. As you can see in these images, where Kevlar structure is being used at the joints area to make the joints bear much larger loads. Now, technological advancements in fabric technology have allowed us to make thin and strong gas-tight fabrics, which are polyester based. There are two main types, laminated and coated. In the laminated fabrics, you take two fabrics and you laminate them together, such as Tedlar and Mylar, both from DuPont, proprietary items. But if you laminate them, then one of them is very good in strength, the other is very good in gas retention. Or you could use a nylon-based strength load-carrying membrane and you can coat on both sides. One side with polyurethane and one side with polycarbonate. So one side allows you to have better gas retention. The other side, exposed to the atmosphere, will have better resistance to the atmospheric aging. Let us see how these cargo airships are finding their place in terms of speed, cost, and the supply chains. So airships occupy a mid-range niche, as I mentioned, between slow and cheap sea and fast and expensive air freight. Now, if you look at the cost in rupees per ton kilometer for trekking, it increases faster with the distance for airships. So this cost for trucks is more sensitive to the distance as compared to the airships. And also airships allow you to depend less on the infrastructure. For example, you don't need a road. So these are some numbers for the cost per ton kilometer for various modes of transport at various speeds and what kind of infrastructure is needed and how much is the time taken. So if shipping can take 7 to 10 days for transatlantic transportation, but you can't do it by rail and truck because they will not be able to do it within 3 days also. And ships, of course, is possible, but you need water. So what is the difference because of airships? One is remote areas where you don't have other modes of transport, whether you don't have roads, when you don't have development, but you want to explore and you want to transport some equipment. Those could be used by companies for their logistics. Then in very cold areas, it is difficult to transport items required by the military. So logistics of military can be handled by airships. And then we can also look at oversized loads, such as turbine blades, which are more than 70 meters in length. How the hell do you plan to carry them on the road? You will cause road transportation disturbance. And also, if you don't have infrastructure or if the infrastructure is damaged, then it will be very difficult to service the disaster zones by other modes of transport. So transport airships can also be used for scheduled supply and emergency response to some situation in the Arctic Ocean, where it will be difficult to mobilize the aircraft. Now let's look at the environmental impact of a conventional airship. So since we don't have any modern rigid airships for cargo, we have just taken the data of old existing airship. This is the USS Macon from the Goodyear Zeppelin Corporation, ZRS-5. You can see that it can travel from, say, Mumbai to Bhopal, if allowed to go on a straight line, at about 102 kilometers per hour with 20 tons of cargo. It can cover a distance of 657 kilometers from Mumbai to Bhopal. Okay. Now, let us see how sustainable transport can result in greener skies. So if you look at the airship, fuel consumption is very, very low, 0.098 kgs per second, and the emissions per kg will be only 3.17 kg. So therefore, same graph comes back again with more detailed information. We have done 2 studies and made 1 prototype. The 2 studies are shown in the long rectangle, the Macon modern diesel engine and Macon diesel engine and Macon. So you can see that cargo ships and rails are the lowest and the aircraft is the highest. Now, what happens if you bring in electrical airship? If you bring in electrical airship, you have improvements across the board. As the photovoltaic technology is improving, we now are looking at 8.1 Gbps on our campus. So 11.1 is actually a very large value. Already we are looking at 8 or so. Low carbon hydrogen is also another way of minimizing but not eliminating. So there is also something like route selection. So between Barcelona and Valencia, we have chosen some route and we have transported some items. But the question here is that none of the existing models or codes are actually very good for this particular application. This already I've shown you, so I don't want to repeat. I just want to highlight that electric airship will be about 400 times less polluting than an aircraft. Let's now have a look at some of the modern cargo airships which are under development worldwide. The first example I want to give is that of Pathfinder by the LTI Research Corporation. This is having a hybrid propulsion system with 24 batteries and 2 diesel generators, each of 150 kilowatts each. All over the body, there are 12 electrical motors, but primarily they are mounted on the sides and on the fin and rudders to identify themselves and to also ensure that the fuselage is not getting too much affected. This particular airship today can cruise at 120 kilometers per hour, and travel 4640 kilometers. That is the ultimate aim for the range. This is not what Pathfinder 1 does, because that is a prototype. This is what they want to achieve with an airship based on this particular prototype. They want to carry 14 passengers and 28 tons of cargo. The next important player in this field is this particular company called as Flying Whales, which is based in France, but they are tying up with many companies, including in India, for developing or at least finding applications for their airships in our country. Atlant 300 is supposed to carry 165 tons of cargo. So I think they are still going by semi-rigid technology because they are saying that the bottom half of the envelope is going to be fully composite, and that is where we will use. But these are estimates on the load carrying capacity of aluminum, etc. This is not driven by actual market requirement. They would like to attempt a prototype that goes so far and so fast. But look at the volume to carry 165 tons of cargo. Look at the volume. It's 311,500 cubic meter. 3 times more than, for example, in NT. So they have gone for certain studies related to hybrid engines, diesel and turboshaft. And if they come up to a conclusion, fine. If not, then we will fall back to HAL. Sorry, we will fall back to the sponsoring agency to do this project. But the gensets here are diesel and hydrogen fuel cells. ML868 is from a company called as the Worldwide Aeros Corporation. They have been talking about airship for a very long time. They have been flying prototypes also, but we are not aware about their actual time to the market. But whenever they present something, they generally give us a ballpark value. And that ballpark value in 1923 is what you are seeing. Okay, so this aircraft actually is supposed to carry 250 tons of payload, fly at 120 kilometers per hour, over 10,000 kilometers. Okay, and they have made a prototype. They claim it does all these things, and they would like to do a demonstration. There is one company that supplies hydrogen all over the world. So they got a brilliant idea that if we are supplying hydrogen, why can't we fly an airship with hydrogen and let them take out the air they want? So this company based in the US looks at a hybrid hydrogen fuel cell, and some energy blocks from power together to generate electricity. It's a good idea to have a look at their concept, but remember, this is not an airship company. This is a hydrogen supply company. So we have to look at their number with a pinch of salt. We don't know exactly, but this is what they claim, that the area that we are going to occupy is going to be equivalent to 42 football teams. And total cost of operating this particular cargo airship coming to 0.32 tons mile as per their estimate. Then we have from Russia a project called as A600. This is a lenticular rigid airship. A lenticular shape essentially is a shape that remains like a disc. So their idea is that the central portion will have the power plant, and you can use it to attach large cargo like this electrical tower component, take it to the place and do an in situ fabrication. They are aiming for 600 tons of cargo. I don't know whether they'll achieve it. They're aiming for a range of 8,000 kilometers. And they are looking at us to provide them the solutions for the turbo machinery related aspects of these aircraft. Now, that was all I wanted to talk to you about sustainable aviation. We will now move on to some questions which have been asked by the learners on the discussion forum. One general question by Gudi Metla Nagaraju is, how can students prepare themselves for careers in aerospace research and industry? So my simple answer is that by making your fundamentals in aerospace engineering strong, and if needed, you can supplement them with the courses on NPTEL. So that is how you will be able to acquire a level of competence due to which a company that is going to deal with aviation products will be happy to hire you. So, खुद ही को कर बुलंद इतना. That is what I would like to say. Equip yourself. And in our Google form, there was a option given for people to have a separate interactive session with me to learn more about aerospace research and industry experience. I only want to make a statement that there are more than 880 learners enrolled in this course, of which 265 have also registered for the examination. So it will be impossible for me to find time to meet each one of you. Okay. So if someone has any genuine requirement, which is beyond the realm of this monthly interaction session, I'll be happy to set up a meeting with you, which to send me an email. I can communicate a mutually convenient time. But promising is not possible for everyone. Only in specific cases we can do it. This is a time for people to give us some feedback. We have been asking this for last so many years. Unfortunately, there are not many people who have come back to us. Many people think that once the course is over, our relationship ends. But that is not the case. I am in touch with all my ex-students of LTS systems. If you still get some idea or a concept, you are welcome to share your feedback. Maybe right here, start with, in the discussion forum, or you can send it directly via email. The discussion forum, friends, is for you to use. The teaching assistants are regularly monitoring that system. The discussion forum allows you to ask questions, interact with me through my TS, beyond the videos that you have seen. But it is up to you. You have to take efforts to ensure that you are not, you are not just asking some help unnecessarily. So with that, I would like to end the session today, reminding you that we have two teaching assistants who are right now also sitting with me. One is Akhileshwar Munshi and the other is Purvi. Both of them are doing a wonderful project under the NPTEL Post-Baccalaureate scheme, which, as you might know, has been announced recently, like last year by NPTEL. I have also put a proposal for this year. One proposal, which was primarily created by Akhileshwar, has been edited by me and submitted to the NPTEL. So if you happen to be eligible for NPTEL Post-Baccalaureate Fellowship, I would urge you to consider applying for internship with me. And now we have come to the last slide of the presentation where we will open up for any queries. The queries can be either asked on this YouTube channel by unmuting yourself, or you can type it in the chat window, or you can also type it in the window on the YouTube live. But this meeting is currently on Zoom. So therefore, if anybody is there on Zoom with the meeting, and if they have any question, we'll be happy to unmute you and answer the questions. Thank you so much. I am stopping the share and I'm opening the floor. So, which is the best email ID to reach you? So, well, my name is Rajkumar Pant, and if you just add @gmail.com, it will come to me. That is the fastest. But in my chat window, I'm typing my official email ID, which also gets forwarded to my Gmail account. You can send it to me either at rajkumarpant@gmail.com or at rpant@iitb. Don't send to both of them because they ultimately come to Gmail. So there'll be no benefit in sending it to both of them. Are there any more questions? Otherwise, we will leave the meeting. Okay, so let's stop the meeting then.